Alright, this is a video for probability, and this is to help you understand problems that are similar to the birthday problem, but a little bit easier. So the problem looks like this. You spin the spinner 3 times. What is the probability that you get the same number at least twice? So there goes the spinner, although it looks like it's just jumping around all over the place. But either way, as long as it's random, it doesn't really matter. And it goes through 3 times. What is the probability that you get the same number at least twice? Let's make this a little smaller so we have more space to write. But we'll leave it there so you can see what's going on. Okay. Well, we need to really think about this, what this means about getting the same number at least twice. And sometimes it's easier, instead of directly trying to find that probability, where we're looking for a list of outcomes, all the possible outcomes, and searching for the ones that have either 2 or 3 of the same number, that might be a little bit cumbersome, a little bit too difficult. So one idea is to find the complement. And the complement of the same number at least twice is not at least twice. So not at least 2 of the same number. What does that mean? Not at least 2 of the same number. Well, at least 2 of the same number means either 2 of the same number or 3 of the same number. So not at least 2 of the same number would have to mean all different numbers. So that's what the complement, the opposite of not at least 2 of the same numbers, means. That's what it is. So they're all different. And that's going to be easier for us to compute. It's easier for us to figure out if they're all different. So it's a little bit slow here in this video because it's kind of difficult to write using the instruments that I have right now. So hopefully in the next videos will be a little bit faster with my writing. Okay, so we need to find the probability that they're all different. But remember, that's not the probability that we're actually trying to find. That's the complement. So once we find that, our job is not finished. So the probability that they're all different is the probability that the second is different from the first and the third is different from the first 2. So that's what we need to find. The probability that the second spin winds up being different from the first spin and the third spin winds up being different from both of the first 2 spins. I'm not sure why this is going so slow, so I'm trying to speed it up here a little bit. But the probability of the second being different from the first and the third being different from both, well, we know that a shortcut to figuring that out is to find the probability of each of those things happening individually, and then we can multiply them together. So we need to find the probability that the second is different from the first, and then we'll multiply that by the probability that the third is different from both the first and the second. So let's look at the first part. Let's find the probability that the second is different from the first. Well, there are 8 possible outcomes, and the first one could only be one of those outcomes, leaving us with 7 possible outcomes that are different from the first. For example, if the first one was an 8, the second one could be 1 through 7 and still be different. If the first one was a 4, the second one could be 1, 2, 3, 5, 6, 7, 8, and still be different from the first one. So the probability that the second is different from the first is 7 out of 8, because there are 7 opportunities for the second spin to be different from the first. Again, there are 8 total possible outcomes, total possibilities for both spins, for either one. And there are 7 possibilities in which the second one, the second spin, is different from the first spin. So the probability of the second being different from the first is 7 out of 8. Here we go. I think I figured out how to speed it up, maybe. All right, so now we need to find the probability that the third spin is different from both the first and the second. So I'm sorry that this is getting a little messy. Again, this is only the second video that I'm making. I'll get better. So the probability that the third is different from both of them is 6 out of 8, because the second one and the first one each were different, leaving us with 6 left that have not yet been hit. So for example, if the first probability, or if the first spin was a 1 and the second spin was an 8, we could get a 2, 3, 4, 5, 6, or 7 for that third spin and still be different. So there are 6 opportunities for the third spin to be different than the first 2. So now we know the probability that the second is different and the probability that the third is different from both the first and the second. So all we have to do is multiply those together. So we get, well, 7 out of 8 times 6 out of 8. 7 times 6 is 42. 8 times 8 is 64, because we know how to multiply fractions. But remember what that was. That was not the probability we were looking for. That is the probability that (42 out of 64 is the probability that they were all different. The complement is the probability that not all of them are different. In other words, that at least 2 of them were the same. And that is 22 out of 64. Because if 42 out of the 64 possible outcomes, all of them were different, then 22 out of the 64 meant that not all of them are different. And saying not all of them are different is just another way of saying that at least 2 of them are the same. So the probability that at least 2 are the same is 22 out of 64, which if you divide 22 divided by 64, you get approximately 34.4%. On your homework, you need to leave it as a fraction, not a percent, or the computer won't recognize it as a correct answer.